Okay, so it is May 1st. A little bit. And we are still looking at section 6.2. We are finishing 6.2 today. Volumes of solids with known cross sections. Day 2. And really, I just have one example we're going to take a look at today, one example with a part A and a part B, and this should probably do it for everything that we need to be able to work with these problems. Our example for today, a solid has a base given by the region bounded by y equals the cube root of x and y equals x squared. We want to find the volume of the solid with cross sections of, well, various shapes that we'll deal with in a moment. And this time they're going to be perpendicular to the y-axis. We spent Thursday looking at how to deal with these things if they're perpendicular to the x-axis. Now we need to deal with perpendicular to the y-axis. And of course, your first step is what? Do that, please. So we've taken care of all that stuff. The first shape we'll deal with, squares, because that's a good place to start. Hopefully we have a region like that little ovally shaped thing that we have over there. Nice points of intersection. They intersect at 0, 0, and what's the other one? 1, 1. What's different this time is the cross sections are perpendicular to the y-axis. So to draw in my bases, I'm not going to draw little vertical lines. I'm going to draw some horizontal lines. And those are the bases of the squares that are coming up out of the page towards you. So we're dealing with squares here. And the base of my square is just one of those strips. Can't really see that, but base matches up with one of the strips over there. Do you think I should do a top minus bottom thing? Right minus left. Now, here's the part we need to be careful of. Shall I say the thing on the right is x squared and the thing on the left is the cube root of x? Or do you think I may have to try something different? Like what? I completely agree with what you said about the right minus left. Okay, so we just had a quiz with those solids of revolution. When you had those horizontal radii, did you use functions with x in them? I hope not. What did you use, hopefully? Functions of y, right? We had that rule that when we were spinning things around any sort of vertical line and had horizontal strips. I'm wondering if we all use functions of y, maybe not. We should have used functions of y when we had horizontal strips. And the same deal over here. Whenever we have these little horizontal strips that happen to be bases, we need to use functions of y rather than functions of x. So, this thing that was y equals the cube root of x, that's the same as saying x equals what in terms of y? Easy. Y cubed. And the thing that was y equals x squared is the same as saying x equals square root of x, technically plus or minus, but I just really care about the positive part anyhow over here, so plus is perfectly fine. So now, the thing on the bottom is the right function minus the left function. Because they're horizontal cross sections, I need to use my functions of y. Thing on the left is the parabola y equals x squared, but I'm going to call it the square root of y, the function of y version. On the right, I have that cube root function, but again, I'm going to call it by its function of y version, so I'm going to call it y cubed. Question, Ronan? So here's my little region. The thing on the right is this part over here. Thing on the right is that y equals x squared, but we're going to call it x equals root y. Thing on the left is the cube root function, but I'm going to call it y cubed over there. Are you okay with right minus left? So, Emily Boyce, what's the formula for the area of this square? How would you find area if we know its base?
The square root of y minus y squared.
Good. We've got our area of one of those squares coming out towards you. I'll try to show you this in a moment on the computer. The volume. I need to integrate that area. I'm going to integrate from 0 to 1. But because those are the x values for the region, or because those are the y values for the region? Like any time we're dealing with functions of y, we're going to integrate over our y values. Usually they won't be kind of symmetric like this, but I'm using my y values over there. Please go to the calculator. Let's type things in. Remember, it doesn't matter that we're calling it y. You can certainly type it in using the letter x. When I did this, my calculator wasn't able to turn it into a fraction, so I just wrote a decimal. If you are able to get a fraction, that's fine. And while you do this, let me see if I can get a picture of what this thing is going to look like. Yes, or those solids of revolution like on your quiz. Chloe, do you have a decimal answer or a fraction answer or whatever?
0.198.
Good. Was anyone able to get a fraction? Nikki?
25/1.6.
That sounds like what people told me in the other class. My calculator couldn't do that. It just gave me the decimal, but I'm assuming that's okay. Just for fun, let me show you what this looks like. Oh, you know what? I can't show you what this looks like because that'll stop the recording. I will show you at the end of class this one and the other cross section we're going to do. But hopefully you can kind of envision what's going on here. Right, Nikki and Lexi? Exactly. Part B. Other questions on how to deal with part A? Perpendicular to the y-axis, functions of y, integrate over the y values, right minus left? No comments. Okay, part B. I would like to deal with cross sections that are right triangles with a base in the xy plane Still perpendicular to the y-axis because that's what it said in the original problem. And we're going to say, and a height that is 3 times the base. Right triangles with base in the xy plane. So here's my right triangle. Rather than like saying the hypotenuse is in the xy plane or something like that. And a height that is 3 times the base. Kendall, what is the base of that triangle?
The same thing, the square root of y minus y.
Good. Remember what I said last time, once we have our base, we're just going to use that for all the shapes. Unless I suddenly start to switch like perpendicular to the x-axis and the y-axis. But other than that, once we have the base, we're good. Julia, what would the height be?
3 times, like the base and
Yeah, 3 times square root of y minus y cubed. I think that should be all that I need to do for you on this one. Keep going. Get your area, get your volume. Again, I wasn't able to get an exact answer, so I just have a decimal. If you can get a fraction, great. Doesn't have to be though. Caitlin Arsenault, what do you have for a final answer? 25 over? Um,
25 over 84.
I think 84 sounds a little better, maybe. I think so. I didn't bother. I just got a decimal. Anyone have a decimal they can share? 0.29. I'll just go with 0.298. Do you get how this is kind of using some of our solids of revolution along vertical line ideas combined with our cross-section things? Functions of y, right minus left, integrator of the y values. Okay, let me stop this. Let me show you.